Hi guys, welcome to lesson 10.3 on defining and using probability. There are a number of definitions that we have to get out of the way first of all in this lesson, but just so to ease some anxiety, this lesson is significantly shorter than the last. We're going to be able to kind of buzz through this fairly quickly, but I want to make sure that I hit some key vocab. If you need to pause this video to write these definitions down, please do so. Otherwise, you can get these definitions out of the back of your student textbook. Probability. We've been talking a lot about counting principles and looking at the total number of outcomes a certain scenario can have. For example, our permutations and our combinations. We've been talking about the number of outcomes a situation can have. We haven't talked much about probability. Probability is a number from 0 to 1 that indicates the likelihood an event will occur. If the probability of something happening is 0, well then that would be something that cannot happen. And we're not saying it's very likely that it doesn't happen, we're saying that it cannot happen. All right? The probability of something being a 1 would be it's something that has to happen 100% of the time. All right? So you can kind of equate probability to a percent. Like for example, a probability of 0.5, for example, is really like a 50% chance of something happening. All right? A probability of 0 is like a 0% chance, and a probability of 1 is a 100% chance. Now, theoretical probability is when all outcomes are equally likely, and that's really important, that all outcomes are equally likely. The number of outcomes in event A divided by the total number of outcomes. We're going to talk more about theoretical probability at the bottom of this page. All right? Now, odds are a little bit different. Odds are used to measure the chances in favor of an event occurring or the chances against an event occurring. We're not talking about every single combination. Now we're talking about comparing success versus failure instead of saying success out of every possibility. So odds are a little bit different and they're calculated a little bit differently than probability. All right? Now experimental probability is a little bit different. Again, very similar to theoretical probability, but experimental probability, as you can imagine, comes from experiments. Calculation of probability of an event based on performing an experiment. So for example, you grab a 6-sided die and you roll it 100 times. How many 4s do you get out of 100 rolls? That's called experimental probability. Now we can go to the theoretical probability of that. We won't get into that right at this time. But again, theoretical is what it should be. Experiment is what we measure by experimenting. Finally, geometric probability is probability found by calculating a ratio of two lengths, areas, or volumes. So this is kind of equated to, like, for example, a dartboard. Okay, so you got a bullseye here in the center. You can say, look, I'm throwing a dart. What's the probability that I'll hit in the bullseye? What we would do then is we would calculate the area of the bullseye and divide that by the area of the whole circle. All right, and that would tell me the geometric probability of throwing a dart and landing in that region in there. Okay, so that's geometric probability. We won't spend a lot of time on that in the lesson, but it's something that I just felt like I should bring up. All right, theoretical probability of an event says when all outcomes are equally likely, which is exactly the definition we just talked about. When all outcomes are equally likely, the theoretical probability that an event A will occur is, and this is read P of A, we say this is the probability of A. Okay, so sort of like a function f of x. Okay, we would say this is probability of A. All right, probability of event A occurring is the number of outcomes in event A. So the number of things that are done in favor of out of all possible outcomes. So the number in favor out of all possible outcomes. And that's really important that you recognize that it's the total number of outcomes for the entire experiment. All the different outcomes that could happen, the number that are in favor divided by all of the different events. This is going to be different when we talk about odds. So I'm just making kind of belaboring the point, but I want to make sure you guys recognize the difference between odds and probability. Okay? And then it says at the bottom, the theoretical probability of an event is often simply called the probability of the event, because again, we're saying that's the theoretical probability, that's the probability it's going to happen. All right? All right, so let's take a look at the top of the next page then. Oops, can't seem to get over to the right lesson. There we go. So there's a checkpointed problem at the top of the next page. I want you guys to go ahead and try these two examples, and we'll be right back with solutions. All right, in example number 1, it says, using a standard deck of 52 playing cards, find the probability of drawing a red queen. All right, so event A is drawing a red queen. All right, how many events are in favor of drawing a red queen? Well, out of a deck of 52 cards, there is a queen of diamonds and a queen of hearts. So there are 2 red queens in the deck. So when we find the theoretical probability of event A, we say, look, it's the number of outcomes that are in favor of getting a red queen. Well, there are 2 events that will get us a positive answer. And out of the whole deck, there are 52 cards. And so we then reduce that to 1 out of 26. And so the probability of that happening is 1 out of 26. You could change that to a decimal. This number is going to be something between 0 and 1, though. All right? So if you wanted to do is 1 divided by 26, you could give me a decimal for that probability. But 1 over 26 is perfectly acceptable. All right? Second example. In example 2, find the probability that 4 of the 7 male players of the baseball team... Oh, I'm sorry. I forgot about this. Example 2 talks about an example that isn't in your text. So for some reason, we're missing a page on this note. So don't worry about this example right here. We won't take any time with that example because example 2 isn't in my scenario. All right? And there's something else quirky coming up about this lesson, but we'll get to that on the next page. All right, so let's go ahead and let's take a look at odds. All right, odds in favor of or odds against an event. All right, when all outcomes are equally likely, the odds in favor of an event A and the odds against an event A are as follows. Odds in favor of event A are number of outcomes in A, so basically the number of times we'll have success. Now in the past, when we talked about probability, we talked about success overall. Okay, when we're talking about odds, we're going to say that the odds of this are the number of outcomes in A and the number of outcomes not in A. All right? And we'll get back to that in just a few minutes here. I want to go back to our card drawing example in just a few minutes because I want to talk a little bit about odds versus probability of that red queen. Odds against an event A are basically the number of outcomes that are not in A versus the number of outcomes in A. Now you'll recognize that these 2 quantities are basically just reciprocals. Okay, the odds in favor of it are the odds of it over the odds against, and the odds against are odds against over odds for. Okay, so it says you can write the odds in favor of or against in the form A over B or A colon B, because again it's a ratio, it's a quantity comparing 2 numbers. All right. Notice that we're not talking about totals here. Okay, we don't talk about the total number of ways something can happen. We're simply looking at comparing the outcomes, whether it's a positive or a negative event. All right. So going back to our red queen from the previous checkpoint, the probability of drawing a red queen was 1 out of 26, whereas you said it was 2 out of 52, which is actually in our case a little bit better. All right, it's 2 out of 52. So then, if we talked about the odds in favor of event A, the odds of A, meaning the odds of getting a red queen, are 2 in 50. All right, 2 to 50, or 2 to 50. All right, now that can be reduced to 1 to 25. All right, but basically the odds of getting a red queen are 2 to 50. The odds of not getting a red queen would be 50 to 2. All right. Again, when we're talking about odds, we're talking about comparing the 2 quantities individually, not the total. All right. And again, I feel like I'm really belaboring that point, but I want to make sure that you guys get the difference between odds and probabilities. Okay. All right. Let's take a look at some marbles here. I got a little bag of marbles over here. All right. So here's my bag of marbles, and in that bag of marbles, I have 6 red marbles. 1, 2, 3, 4, 5, 6. In that bag, I also have 12 yellow marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Also in that bag, I have 9 black marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. That's all the marbles that I have in the bag. Okay? All right. So it says, find the odds in favor of drawing a red marble and the odds against drawing a black marble. All right? So the odds for rolling a red marble, or I'm sorry, choosing a red marble, there are 6 red marbles. All right? There are 6 red marbles. Now, it does me no good to talk about the total number of marbles in the bag because we're not calculating a probability of choosing a red marble. We're talking about the odds of choosing a red marble. So, there are 12 yellows and there are 9 blacks. So altogether, there are 21 other types of marbles. All right? And so since there are 21 types of other marbles and 6 red, my odds of getting a red are 6 in 21. Now that reduces to 3/7 or 3 to 7. Okay, so there's a 3 to 7 odds of me choosing a red versus anything else. Okay, again, red versus anything else, not red out of the whole thing. All right? The number of non-black, okay, well again, the odds against drawing a black would be the odds of a non-black. So how many total non-black marbles do we have? Well, we have 18 that are non-black, so it would be 18 non-black marbles out of the number, over the number of black marbles, which is 9. 18 over 9 is 2 over 1, so that means there's a 2 to 1 chance that we will there's a 2 to 1 odds that we will choose something that's not black versus something that is black. All right? Okay, now, this is the part that I told you was a little bit quirky. If you notice the top of the next page, we go way back to Chapter 8 in simplifying rational expressions. We don't want to go back to Chapter 8 and do this all over again. For some reason, page 270 is a duplicate, and so we're going to skip this entire page, and we're going to get right down to the next page, which is page 271, which is the last lesson, or last page of the lesson. All right, now let's take a look at experimental probability. Again, experimental probability says we conducted an experiment and we want to measure the probability that something happened. Okay, when an experiment is performed that consists of a certain number of trials, the experimental probability of an event A is given by the number of trials that A occurs, so basically the number of success out of the total number of trials. Okay, number of success out of trials. That's experimental probability. Now, if we do this experiment long enough, we would expect that the experimental and the theoretical probabilities will match. All right, but if I only do this event like 4 or 5 times, we might not get a very good sampling. All right, so let's go ahead and find an experimental probability. It says exam grades of students in a history class are shown in the bar graph at the right. Find the probability that a randomly chosen student in this history class received a C or better. Okay, so we want to find the probability that a randomly selected student, we just pick one student out of the crowd, and we ask, what's the probability that that student received a C or better? All right, so the total number of students who took the test is 3 plus 1 plus 8 plus 12 plus 7. Altogether, 31 students took the test. Of those surveyed, now we have to be careful here because we're talking about those that got at least a C. Find the probability that a randomly selected student received a C or better. So anybody that got a C or better, so basically all of these kids over here. So 8 plus 12 plus 7. So altogether, that comes out to 27 students that received at least a C. So the probability of at least a C is the number of successes out of the total number of trials. 27 out of 31 reduces to a decimal of approximately 0.871. Again, notice this experimental probability is between 0 and 1. We would expect it to be. So basically that says there's about an 87% chance that you will randomly select a student that got a C or better. All right, so 2 checkpoint problems at the bottom of the page to conclude the lesson. Why don't you guys try these, and we'll be right back with a solution. All right, I'm not going to draw the bag of marbles again. All together in that bag of marbles, you've got 6 blue, you've got 6 yellow, you got 9 white, and you got 11 green. All right, blue and yellow and green and white. Boy, that's a Michigan bag of marbles right there. Find the odds in favor of drawing a yellow marble. So odds in favor of drawing a yellow marble will be odds for, or odds of a yellow, will be the number of ways we can draw a yellow. Well, we can draw a yellow 9 ways, all right? And we're going to divide that by the number of ways is not, so we're going to say yellow over not yellow. Okay, so how many different ways can I choose a yellow? Like, I can choose a yellow 6 ways. I almost wrote that wrong. I can choose a yellow 6 ways, and then out of those that are not yellow, there are 6 blue, 9 white, and 11 green, so that is 26 that are not yellow. 6 out of 26 reduces to 3 to 13, and so my odds are 3 to 13, all right, or 3 to 13. Either way is fine. In example number 4, find the experimental probability that the randomly selected student received a C or lower. All right, so again, we still have 31 students total. Okay, that does not change. But the total number of students that received a C or lower, we got the 3 that received a failing grade, we have 1 student that got a D, and we have 8 of them that received a C. So altogether, that looks like it is 12 students out of 31 that received a C or lower. As a decimal, that's approximately 0.387%. All right? So that concludes lesson 10.3 on odds and probability.